Hello students, welcome back to this next session on industrial metallurgy. This is session number 3 and we'll continue our discussion on the basic terms in industrial metallurgy. We have already discussed what is meant by the term called phases or microconstituents. Let's now discuss another term called components, and these are the items that we'll discuss in this session. So let's start with the definition. You see, components of a metal or an alloy system, or in general, components of a material system, are the total number of stable individual substances which have their own chemical identity. And if all of them are taken together, they can completely describe the chemical composition of the materials system under consideration at a given temperature and pressure, which is of interest to us. As has been written, in other words, components are the independent chemical species which are present in a materials system. So students, try to appreciate this is a term very different from what we have discussed in the last session, that is phases. Phases were representing discrete different regions present within a material system which have got their own set of chemical composition, physical state, crystal structure, lattice dimensions, and so mechanical properties. So phase is a homogeneous region which, because of all these things, has a unique set of mechanical properties and is mechanically separable from other regions, and those other regions are other phases present in a materials system. But here the components, we are more interested that how do we project or how do we describe the chemical identity of a metal or an alloy system or of a materials system. And here we are saying that all those things, and we'll see that these things can be in the form of elements, or they can be in the form of chemical compounds, or they can be in the form of ions. How many these type of things are existing in a materials system which are chemically stable, which have their own chemical identity, right? And all those items, all those elements, all those ions, all those compounds which are present in a material system which are chemically stable at the pressure and temperature at which the material system is existing are its components. Now the third bullet point states that for all pure substances like water, or a pure iron system, or a pure nickel system, or a pure chromium system, in all these pure substances, there is only one component. So if I say we are having a sample of iron, it has got only one component in it, and that component is pure iron, right? And even so another example that we have taken is of the ice water steam system. For example, water is present at its triple point and all the three states of matter are coexisting. Now this system, if you talk in terms of phases, has got three phases in it because the states are changing. We have ice which is in the solid state, we have water which is in the liquid state, we have steam which is in the gaseous state. So this is one of the phases, this is the other phase, this is the third phase. But if you look at this three phase system, there is only one thing, entity present in it which has got its chemical identity, and that is H2O as a whole. So it's a single component system. So we have taken another example, sodium chloride. Now students, if you talk about sodium is a very volatile metal which has to be stored under kerosene, otherwise it goes away. Chlorine is a poisonous gas. If you by chance inhale it, the consequences might be very fatal. But when these two combine, sodium and chloride, they form a stable chemical compound. They form a stable materials system in which sodium has lost all its chemical identity, chlorine has lost all its chemical identity. The chemical identity, the stable chemical species is only one thing, and that is NaCl as a whole. So though this material system comprises of two different elements, but the component is only one, and that is NaCl. Let's now talk about the systems which are more relevant to us in this subject, and that is metallic systems. Metallurgy is all about metals and its extensions, the alloys. So in metallic systems, the general rule is that all elements that comprise the metallic system are its components also. So if you have a brass system comprising of copper and nickel, there are two elements, copper and nickel, both are its elements. So brass is a two component system. So most generally, the number of elements present and comprising a metal system is equal to the number of components present in it. But yes, there are exceptions. If in a, and before I go to that, the last bullet point on this slide, one of the classifications that we have done for metal systems is on the basis of the number of components that are contained in a metal system. If you have a metal system which has got only one component in it, it's called a unary system. If you have a metal system which has got two components in it, an alloy with two components in it, it's called a binary alloy or a binary system. Similarly, ternary, quaternary, quinary, and similar. So one of the classifications that we do for metals or alloys or in general for material system is on the basis of the number of components that are contained in that material system, and accordingly we'll have unary systems, binary systems, ternary systems, etc. Then students, I said that though it's a general rule that in metallic systems the number of components is equal to the number of elements that have made up that metallic system, but if in your metallic system there are certain constituent elements which between themselves or amongst themselves form some truly stable compounds, truly stable chemical compounds, then the number of elements and the number of components is not the same. Then the number of components would always be lesser than the number of elements. So for example, if you have a metallic system which contains copper, nickel, manganese and sulfur in it, ideally and according to that rule, it should be a 4-component system with each being a component. But if you look at this system closely, manganese and sulfur will always combine with each other to form a stable chemical compound. So there would be only 3 components: copper 1, nickel 2, and MnS the third component. Because generally in alloy systems, we'll see in the lectures to come that metals, non-metals, whosoever are comprising your metallic system will not generally react and form chemical compounds with each other. They'll rather dissolve in each other and form what are called solid solutions. So we'll discuss what exactly is meant by that. So in any metallic system, if there are constituent elements which happen to form chemical compounds between them, among them, then this general rule does not prevail. And finally, most generally we'll be talking about these system steels. So if somebody asks you that generally in plain carbon steels, plain means that